Okay, here we want to look at three problems where we have to find the derivative of the natural log function in various ways. Remember, the derivative of the natural log of x was 1 over x, all right? But we had different rules with the natural log function that were unique in their own right. So the first thing we want to do, let's look at this first problem. Now, if we look at this, we should recognize that this is yet another application of the chain rule, the extended power rule that we've been talking about. Okay, so we can look here and we can look at y prime. This is natural log of x, quantity to the fourth power. So what did we do in the last cases? We brought our exponent down, natural log of x, that's going to be raised to the third power. All right. So let's raise that to the third power. Remember, we have to subtract that exponent. And remember, now this is going to be what? 1 over x. All right. Because we always had to take the derivative of the parentheses, remember? So that's 1 over x. Okay, so now once we put everything in and simplify everything, that's going to be 4 natural log of x to the third power over x. Let's put the exponents in, and that's what we have right here. And we can see how that's moving. It is no different than the work that we've been doing, except for the fact that we now are working with the natural log of x rather than a traditional function. Here, this is a problem where we will have to use what? The product rule. Yeah, nothing changes. It's still the first times the derivative of the second term plus the second term times the derivative of the first. The only difference, we have to use the natural log, so that shouldn't be different. So this is going to be x cubed. Okay, and now what's the derivative of x? I'm sorry, the derivative of natural log of x is going to be 1 over x. Okay, that's cubed times 1 over x. Let's move that over. Okay, plus our second term, which is the natural log of x, times the derivative of the first, which is going to be 3x squared. We all recognize that. So let's go back through it. We have the first term times the derivative of the second, plus the second term times the derivative of the first. Okay, so let's carry on and keep moving forward on this problem. So this is going to equal, this is still y prime, now we just simplify. X cubed divided by x, that's just going to give us x squared plus 3x squared times the natural log of x. Okay, let's move back here. So that's going to be x squared plus 3x squared times the natural log of x. Okay, and how would we probably see this problem of, we saw it out? We would, of course, factor out the x squared. That would be 1 plus 3 natural log of x. All right, 1 plus 3 natural log of x. So that's how we would do a problem like that. Like I said, we don't change our rules. We're still using the product rule. We're just applying the natural log of x here. Now, down here, we can see, and you have to look at your rules to make sure and do this very efficiently. We know that the natural log of x was 1 over x. Then we had the natural log of a function. You had different type of rules, all right? But in this case, when we have the natural log of a function, all right, and you can look back in the notes or study your notes. What we did, we took the derivative of our function of x squared plus 5x, and that will be over the original function. Okay, so in this case, we would have 5x to the fourth plus 2 over x to the fifth plus 2x. Let's go back and put the exponents in here. Remember, the derivative of x to the fifth is going to be 5x to the fourth. Derivative of 2x is 2. And then this is the original function that we were given. So the rules don't change much, but we have to make sure that we're comfortable using the derivative as it relates to the natural log of x and our natural log of functions. And it's the same down the road. We're going to use the same thing with the natural exponential function. So this is just different ways that we use the chain rule, product rule, and the derivative of a natural log function.